Kind of an interesting bug here. Um, yeah, let's just go through this really quick. So basically, um, my bit cross reduce function basically takes a value in the range 0 to 1. And this is not intentional. This needs to be multiplied by 255. But basically what this is doing is saturating to 1 if it's over. I'm not sure exactly how that cast goes, but got an interesting like silhouette kind of look to it. It's got kind of a noir looking thing going on. Just thought it was kind of neat. So the goal of that function is to match the function of go over this really quickly. It's to match the function of the original Dithered Raymarching project. So in this one, it was a hard-coded Bayer matrix and referenced like that. But this is kind of how I've been doing it. So I get my value. These are the high bits, right? So H is the high bits, L is the low bits. So this is one way to zero them out. The other would be to bitwise and with the 0xf0u would be that would be how that would be done. That's hard coding the number of bits, which is not exactly what I'm looking to do right now. And also, this uses these values like this. So what I'm going to need to do is use I'm going to need to do some bit shifting logic to figure out what this value here is going to look like. So it's a floating point value, right? So my function is going to produce a floating point number in the range 0 to 1. And this is checking the bit pattern against an unsigned integer, which basically means well, what does it mean? So it just decides whether or not it's going to get bumped up by a single unit, I guess is the easiest way to think about it. Just this logic is going to look slightly different. So, right, and then we're storing let's see, what is that? Oh, that's maybe not the best way to have written this. Yeah, I guess I'm putting the result back in the low bits variable, then storing the low bits variable, and the original alpha. So that's all that is. Currently I've got this much written. It's not correct. The exponential version is a little bit maybe better. I found Alan Wolf's implementation, and somebody else did something very similar. Both shader toy examples are there, but basically computing some exponential based on the number of bits you've got, offsetting that by, in these both of these examples used a value of 1, but what I'm doing is using the noise value here. I think that works pretty smoothly. Then the value becomes the floor of value times the scale. I actually need to look at that because I'm not sure what that 0.5 is. in any event, it quantizes it to reduce the precision here. So main loop is, or main function here is read from the image, convert to the color space, the desired color space, process the values, which is this function. That's either bit crush or exponential reduce. Then I am going to convert back, right, this function, and then store the final result back. So, like I say, these aren't implemented, but all the conversion functions are already in here. So, and that's also all the noise patterns. But yeah, so and it's going to look very similar to this. So the get noise function looks at the uniform input for noise function. If it's none, you get a 0 result, and that just shows the quantized pattern that's going to be in there. Otherwise, you get the Bayer, you get the monochrome blue, you get the RGB blue, you know, however, whatever the desired pattern is. And yeah, so this, yeah, like I say, this will be doing the same sort of thing. So here I've got conversion to the range 0 to 1, and then I'll be presenting, well, so passing that along as sRGB, XYZ, XYY, these other types of color spaces. Then these functions will be then operating on the converted value, which is kind of, well, that's been that's kind of what this project is about, is reducing the precision in these other color spaces and then kind of looking at what it looks like when you bring it back. I just thought this was a kind of a neat little artifact. It's not the intended result, but this is just, yeah, right, like I say, it's just saturating color channel values. So if I play with some of these, it's going to look strange, but it's just kind of like one of the early like CGA or EGA type palettes, where they only had like 16 possible colors or whatever it was. Because what that cast looks like is, right, the values coming in in the range of 0 to 1. So when you cast it as an unsigned integer, it's either going to go to 0 or to 1. Depending on what that implementation looks like. And and yeah, so that's just kind of where that's at right now.